Okay, so the first part is quite okay to do. You just follow instructions. Pressure equals the force over area. And just put in the values.
It's 300 over 20.
300 over 20. 300 over 20. So you get 15 Newton per cm squared. Then what's the second part? State the value at the
Shouldn't be same throughout.
yes. So the answer is 15 Newton per cm squared because pressure exerted same throughout. Then how do you do part 3? Find the force.
Right, use the same formula, but this time you need to find the force.
Yes, good. And the area is how much?
Like 400.
400. So the force comes out to be a very big number, which is
Like 6,000.
6,000. Okay, so you can see the force has been multiplied like 20 times. Then B part 1. Can you do B part 1? Think about it. Volume. How do you calculate volume? Volume equals what? Area times height, right? Simply you say area times height, so 20 times 5, 100 cm cube. Then how do you calculate the distance Q rises?
Is it the same thing, but this time just have to find like the height?
Yes, it's the same thing. Why? Because the same volume displaced one side is equal to the same volume the other side, right? So you take 100 equals to the area, which is what? What's the area on the other side?
Like 400.
400 times h. So h come out to be 0.25 cm. Okay, so it's not so difficult lah. It just looks difficult. Okay, then come to part C. Actually, I wrote the answer down for you already. So after they push the piston down, it's lifted out again. When it's lifted out again, what happens to the valve? The valve A will open because it will have more pressure at valve A. So this one will push open. Okay, then after that, what happens to valve B? Valve B stays closed. Okay, this one will remain closed. And then what happens to the piston Q? The piston Q will remain at the same height. So it maintains its height over there. So this is how the car jack works lah. To lift the car of your Supra. Okay, you want to change the wheel, you have to do that. Okay? Okay, now in a hydraulic system, why do you use oil, not air? Something about the properties of liquids. Oil can be or cannot be. Which one? Cannot be compressed, right? So oil cannot be compressed. So the property of oil is that oil cannot be compressed. So if it cannot be compressed, means that it will transmit the pressure exerted on it easily. Okay, so that's why I use oil. Anyway, this is more of the next chapter where you learn kinetic theory, which you are in now. Okay, so
It's so funny, man.
Look at question 5. This one not so easy. You look at this. You have a trapped air in a tube, like a test tube, that kind. Okay, so you got W, X, Y, and Z. Jonathan, look at the question. You play your calculator. W, X, Y, and Z. Okay, so they're asking you what is the arrangement of the tubes according to the volume of air in decreasing order. In decreasing order, that means from the highest volume to the lowest volume. Okay, so that's what they're asking you. But before you think about that, this is not really a syllabus, but I did tell you lah, and I think you should also know lah. Okay, how is pressure and volume related? You just think common sense one. The smaller the volume,
lower pressure.
lower pressure. Small volume, lower pressure. Higher, right? So it's like that, right? Correct not? Inversely related, right? So they are inversely related. That means if the volume goes down, the pressure goes up, and if the volume goes up, the pressure goes down. So they are inversely related. Okay? So you must know that first. Okay, then now you look at these 4 cases. You all look and you tell me in which case here W, X, Y, Z will the air suffer the highest pressure? Will experience the highest pressure? You think most common sense. Which one? The air, right? There's air inside each of them. Here, 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 here. Where does it experience the greatest pressure?
Why?
Test tube Y, right? Okay, can you tell me why you say test tube Y?
I have no idea.
Pressure always due to what?
Height.
Whatever there is, I always tell you.
Above.
Above. So Jonathan, what's above it?
The liquid.
The liquid and
atmospheric pressure.
pressure of the liquid and atmospheric pressure. Correct. Good. Okay. Hey, write down this one. Like that, right? Wait. Look at. Are you looking?
Yeah.
Okay. Now, that is Y. Okay. So this one has the greatest pressure. So if this one is the greatest pressure, that means the volume will be the least lah. Okay. Now we look at W. How is the pressure of W? What is the pressure of W due to? What do you think?
The test tube.
Huh? Due to the test tube?
Maybe just because of atmosphere.
Huh? What do you say? For W? Atmospheric pressure will act in all directions.
So maybe just like atmospheric pressure.
Yes, this one only experiences atmospheric pressure. How come it doesn't experience pressure due to this? Because this one is acting downwards. Alright? So this one is only pressure of W, pressure W equals to atmospheric pressure. Correct. Okay, good. Okay, now you look at X. How is X?
It's the one applying pressure.
So pressure of X, how is it related to the atmospheric pressure? Or you see easier if you look it the other way around. You look it this way. You see it this way. Atmospheric pressure, which is here, is equals to what?
Equals to
Whatever is above. What's above?
air.
Equals to what? What's above it? The pressure X, right? This thing here, right? And then also the liquid, right?
Yeah.
So this is the pressure of the liquid, right?
I thought atmospheric pressure can't go upwards.
Pressure, atmospheric pressure acts in all directions.
Oh.
Okay?
And then how does liquid also act? Shouldn't it like go down?
See, because the atmosphere, the air molecules are moving all directions, right? So as they move, they exert a force upwards. So there's a pressure upwards. Whereas a liquid, the weight is always acting downward, right? So that means this atmospheric pressure is equal. Okay, if this one holds if this one doesn't drop that means this thing is equal to whatever that's above it, correct? But if above is more, then the whole thing will just fall. Okay, but it's very unusual being like this. So in this case, your pressure at X equals to pressure of atmospheric pressure minus pressure of the liquid. Okay? You understand what I'm doing? Okay. So, and then you got Z. This one, pressure of Z and pressure of Y, which one is bigger? What do you think? Quite common sense. Pressure of Y and pressure of Z, which one will be bigger?
You know why, right? Same.
Same?
No wait. Pressure of Y.
Pressure of Y. Yes. Pressure of Y will be bigger than pressure of Z because this one is an angle. Okay, at an angle, so you don't get a full weight like that acting down on it. Okay?
I thought pressure was the same at all levels.
Pressure is the same at all levels. See, this one is acting directly down. This one is acting at an angle towards this. So this one will be smaller. Okay? So you see like this, can you tell me which one is the...
D.
Wow, you're so fast. So the one with
So
the...
Y is the biggest one, then Y is the only one at the last part.
The one with the least pressure will have the greatest volume, right? So that means this one, the volume the biggest, largest, followed by which one next?
W.
W. So X,
So D will be correct.
then W, then Z, then Y. Okay? So this is how you get it. Okay, so importantly, you must be able to see how to find the pressure inside that little trap air. Okay? Okay, so if you understand what I say, okay, look at 7. Okay, you all try 7. It's similar in idea. Clearly, you will know that P1, the pressure is more than P2, so it's going to be A or B. High pressure, volume will be lower. Right? And then if it's low pressure, volume will be higher. Okay, so which one is it? What do you think?
That means the answer is D.
The answer is B, right? Because the volume of P2 should be bigger since P2 is higher, right? Okay, correct. So the answer is B. Okay, so that's the whole idea. You must see how things are related. So Jonathan, over here, this is P1. P1 is equals to what's above?
Whatever's above 5 cm and atmospheric pressure.
5 cm or what? What's this? Mercury, right? Is it mercury?
Yeah.
Is it mercury, right?
By a thread of mercury.
And atmospheric pressure, correct. Then Shahir, this one P2 is equals to what?
Atmospheric pressure. Just atmospheric pressure.
Only atmospheric pressure. Atmospheric pressure acts in all directions. Okay, this pressure acts downwards, so it doesn't affect. This one and this one is like that. Okay, write it down. So the next time you see, you will remember. You don't. How come? Why is it? It's only atmospheric pressure. You will forget already. Very easy to forget on this. Okay, so you write that down. Understand this. Okay. So for A part 1, atmospheric pressure, look at which one? Look at P, right? Then from P, you simply just have to say the atmospheric pressure is equal to 72 cm Hg. Right, because this one is a vacuum, so we look at this. Then the pressure exerted in pascals by air. Okay, the mistake a lot of people make is just say pressure air is equal to 15 cm. Wrong. It's 15 cm of air, in the sense correct, but you can't do anything. That's why you're asking for density of air, all this you don't know, right? So how? So all this you got to form the relationship, and it's always good to start from the bottom. So here is atmospheric pressure, here is atmospheric pressure. Okay, the atmospheric pressure equals to what is above 16 cm Hg of mercury plus the pressure of air. Okay, that's one way. That's how you all both do it. There's another way. Look, I show you the other way. See, here is pressure of air. Correct or not? There's also one more place pressure of air. Remember what I said? Pressure at the same level is the same, right? So where?
That's like 72 by 60.
Over this side, right? Correct, right? So here, also pressure of air. Then from here, you look up. How much is it? 12, right? Okay, so you can do two ways. You can just say You just look from here, pressure air, here also pressure air, that means here is 12 cm Hg. Correct. Or you can do it this way. So you must be very flexible lah. Okay. Problem is Jonathan is not very flexible lah. Correct or not? So this one become 12 cm Hg. Then after to convert to pascals, rho Hg the thing, and Jonathan says, remember, must convert everything into meters. Correct. Okay. Okay. B is in the next chapter, thermal properties. But I think you all know lah, if you push down Q, if you push Q further down, how will the pressure change? You push it further down. Push the tube further down. How will the pressure change? Increase or decrease? Common sense. Pressure will increase, right?
Yeah.
So if the pressure increase, the volume will
Decrease.
Okay? Then you will learn in the next chapter. I will tell you why. In molecular terms, why? Okay, that one I leave for next chapter. No point telling you now because you don't know yet. Okay. Okay, do the next part. This you just read, you should get it. So it's a less dense liquid. So this will cause a vertical height to change. Everything else you do, the diameter change lah, you tilt lah, you push further down, the height remains the same. Okay? So that was easy enough. Okay, Jonathan, over here, pressure of gas, correct?
Yeah.
Over here, what's here?
Where?
Here.
Atmospheric pressure.
Correct. Okay, so, and then X is 20 cm down, so here is X. Okay, so pressure of gas and atmospheric pressure, which one more? You look lah, pressure of gas like that, atmospheric pressure like that, so which one push down further? So the pressure of gas is more than atmospheric pressure. More by how much? Look at the difference. If they are 60 cm. Okay, this is 60 cm of water, not mercury. Okay, so another way you can see is here is pressure of gas, here is also pressure of gas because they are at the same level. Then from here you look up. What you have above, you have 60 cm of water and atmospheric pressure. Okay, so
Wait, so is the pressure in water like 6,000?
for what?
For water, for inside the water.
Inside the water, yes, it's 6,000. How do you calculate that? Okay, wait. Atmospheric pressure is 100,000. Okay, now let's do everything in pascals. Then this one is rho Hg, right? So 60 cm convert to meters.
Wait,
0.6.
The atmospheric pressure is 100,000. You already say the question.
Yeah.
Oh, okay, that was solved already.
Hey, you never see. Rho Hg, density of water 1000. G is 10, so what you say is correct, 6,000. So this one 6,000, this one 100,000, so it comes out to be 106,000 pascals. Okay, so whenever you see the pressure of gas is more, you add the difference. If it's less, you minus away the difference. Okay, so part C. So this one, next part, you're just using the same formula, pressure equals force over area. Then 10,600 over the 4 times equals the force. Area is 10, so it's a very big number, 10,106,000 newtons. Okay. Okay, so for part D, if you use a denser liquid, If a denser liquid is used, the height h will decrease because why? Because h equals to P over rho g. This one never change, right? This 2 never change. This one denser, bigger value, so h will go down. Okay. With a plank.
Pressure applied on the wire as the plank has a wider surface area, thus less pressure is applied.
The surface area will increase. Hence, less pressure exerted as pressure equals to force over area. You must quote the formula. Okay, so less likely to sink because now the pressure has gone down because the area has gone up. Okay, so commonly asked question, also not too difficult to do. Okay, last page of questions. Question, next page. Try this one. When P is pushed down, right? So it displaces a certain volume of liquid, right? So the volume of liquid, volume of P will equals to the volume of Q, right? The volume must be the same now, if not the liquid go where, correct? But because the area is different, that's why this one moves down more, this one moves down less, correct? Like what you say, okay? So you just, proper working Jonathan looks like this, volume of P equals to volume of Q. So 1.5 times 1.5 times what? 2, right? Equals to, over this side, how much? 5, right? 5 times distance. So distance equals 0.6. So Jonathan, this is proper working. Write down proper working. If you don't write like that, you next time also cannot remember how come you can do it. Okay, so the volume displaced by each side must be the same. Right? Okay, a submarine undergoing testing brought through some dives in seawater, density of seawater and mercury is given, atmospheric pressure of sea level was found to be 750 mmHg. I think for this question, you can do part B easily. I hope so, at least. But part A, when they ask you this, what is meant by 750 mmHg, what will you write?
Like atmospheric pressure acting on like seawater by 75 cf.
How do you explain this? Okay, you have to explain it in words properly, okay? So it means that the atmospheric pressure acting on the seawater is equivalent to a vertical height of 750 mmHg, 750 mm of mercury. Okay, so I think most people don't know how to write this out properly but that's what it means. Okay, that you have a vertical height of 750 or 75 cm of mercury in a tube that is equal to the,
because like the atmospheric pressure acting on like the seawater is not like equivalent to a vertical height.
yeah. So what can cause this error? You're correct. So what can cause this error?
Maybe like trap air.
Yes. right? So you are correct, huh? So you say that Q not measuring accurately because it only measures atmospheric pressure to be, what is the atmospheric pressure according to Q? How many cm or mm, Jonathan? For Q is measuring how much atmospheric pressure?
Wait. Q is measuring
Atmospheric pressure of how much? Okay, so Q only measures 720 mmHg, whereas it's supposed to be 750. So a possible reason for this is there is, like what Shahir said correctly, trapped air in the tube Q. Okay, so there is some trapped air possibly over here that is causing this error. Okay. Okay, for the part 1, or you can do pressure of E just what's above. So this is, what's the answer for E? 1 meter minus
1 meter minus
0.
2 then
Minus
0.4,
which gives you
0.35.
0.35. Then convert mmHg 350 mmHg. Okay, so that was part 1. All both you can do. Okay, part 2 also can do. Okay, next part C. Cannot. Why not?
Just practice.
Because everything forgotten. Pressure of submarine at 70 meters is due to whatever is above. So what is above? You have 70 meters of seawater and you got the atmospheric pressure. So 70 meters, Jonathan, tell me the working. 70 meters convert to pascals is 0.7 times.
But it's already in meters.
Sorry, you're right. It's already in meters. So it's 70 meters rho times 10 times
1025.
Okay, plus atmospheric pressure, how much?
0.750.
This is 0.7 by the 10 times 13,600, right?
Yeah.
And you will get the answer here. Correct. Very good. Okay, now last question for pressure. Read it. Okay, so in part this question you see the vertical height is both the same for both of them, and pressure equals to rho hg. So that means the pressure exerted for liquid S and T is the same. So that means the answer is D. Okay.